Morning, students. Today we are going to start with one more session for the past papers of AS. And today we are going to do with 961811 May June 2023. 1 hour, 30 minutes is the time allowed. I'm not going again with instructions and the information as I have already gone through them. Question number one, what does that say? Images are being created to advertise holidays. Some of the images are bitmap images and some are vector graphics. Okay, some of them are full images and some of them are with just the outline. That means the vector graphics. Complete the table by defining the image terms. Okay, now number one, drawing list. So what is the drawing list? It is the list of all the objects that will be utilized in a particular image. Okay, so you can write it down. List of all items in an image. Now pixel. What is the pixel? Smallest element of an image. Is termed as a pixel. Color depth. What is the color depth? Now, the number of the bits utilized to represent each color, or the number of the bits utilized to represent per pixel. So, per each color is much more better. So you can write it down. Number of bits utilized to represent each color. Coming towards part B, what does that say? The bitmap images are photographs of the holiday locations. Color depth and image resolutions are both included in the file header of a bitmap image. Identify two other items that could be included in the file header of each photograph. Okay, now what could be the other things that could be added up? So it could be the location of that particular data. It might be the dimensions or the size of that particular data. It could be the compression or the type of the compression if it has been utilized. And it could be the file type as well. Okay, so what we could write it down, file type, number one. The other thing that we could write it down, compression type. What compression type it is utilized. Coming to the next question. What does it say? One of the photographs has a bit depth of 8 bytes and an image resolution of 1500 pixel, width and 3000 pixels high. Calculate the file size of the photograph in megabytes. Okay, now right now it's in the pixels, and they are saying one photograph has a bit depth of 8 bytes. Okay, now first of all, what you need to do, you need to calculate the total pixels. So what you are gonna do, 1500 into 3000. Now this will give you the total number of the pixels, but they are saying that the bit depth is 8 bytes. So you need to multiply that answer by 8 as well. So you can directly do it right now. So what you can do, 15 threes are 45, and then 45 you can directly multiply by 8. So 45 by 8 will give you the 8 fives, 40, 0 for carry, 8 fours, 32, 32 and 4, 36. So this will give you the value for 360, and then how many zeros will be added up in all? 5 zeros will be added up in all. 3 and 3 overall. 6 zeros. Okay, now this is the bytes. But we need to convert these bytes into megabytes. So we need to divide this answer first of all by 1000 for the kilobytes and again by 1000 for megabytes. That means divide by 6 zeros. Okay. So that means 3 zeros will be obsoleting these 3 zeros. The remaining 3 zeros will be obsoleting these 3 zeros. And finally, we will be getting 36 megabyte as an answer over here. Coming towards part C, what does it say? It says the photographs are compressed before they are uploaded to a web server. Customers download the photographs from this web server. Explain the reason why compressing the photograph will benefit the customer. Okay, now they are saying that the photographs are compressed before the upload. So to a website. Okay, now they are saying once you are going to download, that means just assume that you are a customer. So what will be the benefit of compressing this thing or to you? That means to the customer. Okay. So it's for 3 marks. So that means 3 points. You need to write it down. Less time will be utilized as well as less bandwidth will be required to download a file and can be fixed in a limited space as well. So this could be the 3 points, or that could be the three benefits over here. Now they are saying for part C2, an image can be compressed using RLE. Explain the reason why RLE may not reduce the file size of a bitmap image. Give one example in your answer. Okay, so RLE, why it won't be able to completely reduce that particular thing. So they are saying that RLE is the reason why it is so. So RLE is the thing that compresses the consecutive or consequently repeated set of the data. But over here, when it comes with the bitmap image, so it won't be having that particular similar data or consistent data that will be coming in the consistency. So that is the reason that it won't be able to compress it fully over here. So we could write it down. RLE compresses similar data or similar sort of data in consistency, but in a bitmap image, data, sorry, data won't be consistent. So RLE cannot reduce it. Okay, now 2 points for explaining, and they are saying give one example in your answer. So example, red, green, blue will give red one, green one, and blue one. I'm sorry, I didn't care about the space over here. You need to write in the lines. I'm sorry about that. Okay, now coming towards question number 2. What does the question number 2 says? It says an organization uses a database to store data about the types of the bird that people have seen. The database is managed using a database management system, DBMS. State what is meant by the data dictionary and give one example of an item typically found in a data dictionary. Okay, now definition of a data dictionary. So data dictionary is data about the data in a database. So this could be one of the definition, that actually it is the data about the data that is stored in a database, or you can write it down the elements that are going to be stored in a database. It could be this thing. Okay, now they are asking for an example, so it might be the table name, it could be the field name, it could be the name of the attribute, anything like that, or it could be the data types. So I'm writing over here name of attribute. Okay, now they are saying state what is meant by the data integrity and give one example of how this is implemented in a database. Okay, so integrity means that how you're going to make sure that your data is consistent. So we will be writing it down over here. Methods of making your data consistent. Now, what could be the example over here? You can do with, or you can go with the verification rules, because integrity is always checked by the verification. So you can go with the verification rules or rules you can go ahead. Okay. Now coming to the next part, part B. It says the database birds stores information about the types of the bird and the people who have seen them. Data about each bird seen is stored with its location and data about the person who saw the bird. That means where the data is, where the bird has been seen and who has saw that bird. So the data is about them. Okay. Database birds has the following tables: bird type, that includes the bird ID, name and size; bird scene, scene ID, bird ID; date, location, person ID; and person is having a person ID, first name, last name, and email address. Okay, now they are saying complete the table by identifying two foreign keys and database table where each is found. Okay, so you need to tell about the two foreign keys. Okay, so bird type is having a bird ID, name, size; bird scene is having a scene ID, bird ID. Okay, so bird ID is over here, as well it is over here. So bird ID will be a foreign key. So first of all, it's bird ID and the database table where it is found. So it is found in the bird scene. It is actually not found. You may say it is actually the foreign key in bird scene. Okay, just after that, coming then we do have date, location, person ID. Then in the person we do have a person ID. Okay, now person ID is here as well as it is here. So again, person ID is a foreign key, but where it is foreign key, it is foreign key in the table bird ID. Actually, it is in the person and it is a foreign key in bird. Sorry, not bird ID, bird scene. Okay, coming towards part number two. The part two says our database birds has been normalized. Draw one line from each normal form to the most appropriate definition. Actually, we need to define the terminologies. So before starting, first normal form says no repetition. Second normal form says that no partial dependencies, and the third normal form says no transitive functional dependency. That means no non-key attribute should be dependent. Okay. So first normal form, all fields are fully dependent on the primary key. Okay, that means it's a third normal form. There is no repeating groups in the attributes. That's a first normal form. No partial dependencies, so it's a second normal form. Moving ahead to part three. Now, what does part three says? It says part of the database table bird type is shown. Okay, so we do have a bird ID in that. We do have a name in that. We do have a size in that. The database only supports these data types: character, varchar, boolean, integer, real, date, and time. Now they are saying write a structured query language, that means an SQL script, to define the table bird type. That means we need to create up the table. So when we need to create up a table, so what is the keyword that we are utilizing? We are utilizing create first of all. Now, what are we going to create? Are we going to create a database or we are going to create a table? So they just said that define the table. That means we are going to create a table. So we will be writing out create table again in the block letter because it's a keyword. Now, what table are we going to create? So it's a bird type. Bird underscore type bracket open. Now the name of the fields first of all. So first thing is the bird ID and the data it is containing the characters in it, or you may say it's containing a varchar in it, because varchar in it because it is the variable characters. You may write it down as well, and you may write it down with the characters as well. Okay, so it's up to you. We could go ahead with the characters. Okay, now why I'm saying varchar, because these characters are not having any sort of the arithmetic operators on them. That's the reason we could include it in the varchar as well. So now bird ID. Okay, was there an underscore? No, there was no underscore. Bird ID, and then for character we do write char. The range of the char, now there are maximum of the 4 digits, so we could write 4 or 6, anything. We could go ahead with 5, and then not null. Okay, why do we write not null? That means that there should be a value. We cannot go without any value in it. Okay, not null. Okay, just after that, after the bird ID, what is the other one? It's a name. So name will be completely in a variable character. That means a varchar. Now varchar could have a limit of 15, you may say. Okay. Then after the variable character, we do have a size. Again, this will be varchar. You could again go with 15 or 10. That doesn't matter a lot. Now, just after that, we need to write down the primary key of this thing. So what will be the primary key? First of all, write down the keyword primary key. So what will be the primary key? Out of the bird ID, name and size, obviously it will be a bird ID. So we are going to write it down bird ID over here. Just after the bird ID, it's the end of the bracket and a semicolon. So this is how we do create the thing. Okay. Okay, moving to the next question. Question number 4, what does that says? It says the database tables are represented here for references. Bird underscore type, bird ID name size, bird underscore scene ID, bird ID, date, location, person ID. Person is having a person ID, first name, last name, email address. Complete the SQL script to return the number of the birds of each size seen by the person with the ID of J underscore 123. Okay, now you need to uh, display the things or return the number of the birds. Number of the birds needs to be returned of each size seen by the person ID. Okay, now the ID is given to you J123. Okay, select bird type dot size because they are saying each size. After that, there is a dash bird type dot bird ID. So what will be there? So number of the birds. That means you need to put it a count over here. Count will be utilized to tell you the total number of the birds. As number of the birds from bird type, comma. So bird ID is in both. It's in the bird type as well as in bird scene. So over here it will be bird scene as well. Bird underscore scene. Where? Now where we are gonna say bird underscore scene. First of all, the name of the table dot person ID equals to J123 and bird type dot bird ID equals to bird scene because we are linking up the tables over here. Bird scene dot bird ID. Sorry, there was no underscore over here. So bird scene equals to bird ID over here. Bird ID dash bird underscore type dot size. So you need to group it by group by bird underscore type dot size. So this is how you need to do this one. Okay, now coming towards question number 3. What does the question number 3 says? Our computer has an operating system. OS describe how the operating system manages the peripheral hardware devices for the computer. So you need to tell in detail that how the hardware devices, that means the input and output devices, how they are going to be managed. Okay, so number one, OS installs the device drivers to link with peripherals okay data from peripherals is converted to binary to be processed, keeping a look on any sort of interrupt or error to be handled at meantime. So we do have to convert it, and we need to check it out that any of the interrupt or any runtime error should be handled at the same time. This could be the answer for this thing. Okay. Now, moving ahead to the next part, hardware management is one key management task carried out by the operating system. Identify two other key management tasks carried out by the operating system. So you may write it down: memory management, and you can write it down: security management, file management, error management, multiple of them. So I would go with memory management and security management. Memory management and security management. Okay, now for the part C, what does the part C says? It says the operating system has a utility software including defragmentation software. Explain how defragmentation can improve the performance of the computer. Okay, now first of all, let me explain you that how the defragmentation actually works. So defragmentation actually works in that particular manner that it rearranges all the blocks or all the individual files on a hard drive and put them into the contiguous format. So once it is placing them into the contiguous format, so accessing the data over there could be faster, as well as the data head movement in a hard drive would be less. So if it would be less, so obviously the more data could be stored easily. So now let me write it down with you guys. It rearranges all the utilized memory blocks in a contiguous format, making data access faster and less movement of head is needed. So you could write it down in this particular manner for this answer. Coming towards D1, now what does it say? The computer stores data in the binary form. State the difference between KB byte and a kilobyte. So KB byte means KB byte is 1000 bytes, whereas, sorry, it's KB, my bad. So it's 1024 bytes, whereas kilobyte is 1000 bytes. Moving ahead to the next one. Now they are saying convert the binary number 964 into the BCD format. Okay, now converting the into BCD format, so it's quite simple. What you need to do, you need to represent each digit on 4 bits. So making up a line 1001. For 6 it will be 0110, and for 4 it will be 1, sorry, 0110 for 1. Sorry, my bad. 0100. So this is quite simple. BCD format means that you simply need to convert each digit into the 4 bits. Okay, now they are saying convert the positive binary integer 4 times 1, then it's a 0010 into hexadecimal. So as we know that in the hexadecimal, we make up the pair from on the right hand side, and we make a pair of 4 bits each. So first pair will be 0100, and the last pair will be 4 times 1. So 4 times 1 represents an F. We know that. Second pair says 0010, that means it's a 2 right over here. Now they are saying give the smallest and the largest 2's complement binary number that can be represented using 8 bits. Okay, now 2's complement means that obviously it would be the negative format. So for the smallest, it could be 1 and then 7 zeros. 600. Okay. And the largest means it should be in the, okay, now it's a negative number. Okay. Now for the largest, we need to represent it into the positive. So we will be saying 0 and then 7 ones. So this is how you can say that the smallest number will be 1, and then for 7 times zeros, and the largest number will be 0 and then 7 times 1. Okay, now they are saying add the following two binary integers using a binary addition. Show your working. Okay, so 0 plus 1 will give you a 1. Again, 0 plus 1 will give you a 1. Then 0 plus 0, 0. 0 plus 1, 1. Now they are saying 1 plus 1 will give you a 2. So binary format of the 2 is 1, 0. So 0 at the bottom, 1 at the top. Again, it's making up a 2. So 0 at the bottom, 1 at the top, 1 right over here, and 1 right over here. So this is how you need to do this part. Okay, now they are saying show the result of a 3 places right logical shift on the binary. Right means over here. So that means this one, 1, 1, 2, and 3. This one is going over here. So we will be having 1, then 0, 0, double 1. Okay, now obviously these 3 bits has been obsoleted because it was out. Now, how we are going to complete the byte? So we need to complete the byte by just adding up 3 zeros right over here. So in this particular manner, we are completing up a byte over here. So that will be all for the first phase of this past paper. We'll see you all in the next phase of this past paper. Thank you so much, guys.